Alright, welcome to Lesson 4, Part 1, Triangle Inequalities. We're going to be talking about the Pythagorean Theorem, the distance formula, the converse of the Pythagorean Theorem, medians in a triangle, and some inequalities with triangles. So first, let's just talk about some parts of a right triangle. In a right triangle, there is the right angle, and the right angle is always across from the biggest side. The biggest side is called the hypotenuse. The other two sides are called the legs. The Pythagorean Theorem. If you have a right triangle, I'm going to start first with this top picture and formula. If you have a right triangle with the leg, and the hypotenuse, there is a formula that you can create. It says that one leg squared plus another leg squared equals the hypotenuse squared. And this is true for all right triangles. Another way it's written is like this below picture and formula. You normally see it A, B, C, where A and B are the legs and C is the hypotenuse. And if we are going to use this, we are always going to make C the hypotenuse. So, if you have that triangle with ABC, it's A squared plus B squared equals C squared. So let's go ahead and try a couple examples. I'll do the first one here. So number 1, we see that the legs are 3 and 4, and we're missing C, the hypotenuse. So all we do is we just fill in the formula. 3 squared plus 4 squared equals C squared. This gives us 9 squared plus 6, nope, sorry, not 9 squared. 9 plus 16 equals C squared. Simplify more, and we get 25 equals C squared. Then we take the square root, and it's nice because the square root of 25 is just 5. So C equals 5. Now, I want you to do the rest of these with your group after you pause the video. Then I will work through them. You can see how you did. And if you run into any square roots as your answers, just leave your answer as a square root. So go ahead and pause the video now. Alright, start with number 2. It's going to be 13 squared equals 12 squared plus x squared. Now, again, because this is an equation, we can flip-flop as long as we keep everything on the appropriate side. So this simplifies to 169 equals 144 plus x squared. We subtract 144 and we get 25 equals x squared. Take the square root and we get x equals 5. Number 3, we're going to have 6 squared plus 8 squared equals x squared, which gives us 36 plus 64 equals x squared. 36 plus 64 is 100. And the square root of 100 is 10. So x equals 10. Final one, number 4. 1 squared plus 1 squared equals x squared. So it's 1 plus 1 equals x squared. So 2 equals x squared. And we can't take the square root of 2, so our answer is just x equals square root 2. And next we're just going to do a quick review of the distance formula. And if you recall, if we have a point A with x as points at x1, y1, point B with coordinates of x2, y2, the distance from A to B is AB equals the square root of x2 minus x1 squared plus y2 minus y1 squared. And this actually comes from the Pythagorean theorem. This idea does. So, do this example with you. We have AB and we want to find the distance. So it's the square root of, call this x1, y1, this x2, y2, 6 minus 4 squared plus 2 minus 3 squared. Which leaves us with 2 squared plus negative 1 squared, which equals 4 plus 1, which is equal to square root of 5. So AB equals square root 5. Alright, in your group, I'd like for you to pause the video and do these two problems. Okay, and here are the answers to these two examples. If you want to go ahead and pause the video again to check through, make sure you got it right. Alright, next we're going to talk about the converse of the Pythagorean theorem. Again, this is the Pythagorean theorem backwards, basically. In the Pythagorean theorem, we said if the triangle is a right triangle, then this happens. Well, now we're saying we don't know if it's a right triangle or not. So we don't know if ABC is a right triangle or not. But what we do know is that if a squared plus b squared equals c squared, then we can say that triangle ABC is a right triangle. So, using the converse, we're going to say whether or not a triangle is right or not. We're not going to be solving for any missing variables. We're basically just saying, is it a right triangle or is it not a right triangle? So for this example, what you would do is you would look at this triangle and first identify what the supposed hypotenuse might be. Now if we look at these numbers, we have to say which one do we think is going to be the hypotenuse. And if you remember, the hypotenuse is the longest side, which means it would be the longest, not the longest number, the biggest number. So when you're doing this, you're going to take the biggest number and you're going to imagine that is your C. So you're going to do the other two numbers like their legs, and then your biggest number is going to be here. And then all you do is simplify and see if you can get the same number equal to the same number. So 9 squared 81 plus 144 equals 225. 81 plus 144 is 225. So 225 does equal 225. So if this happens, we can say it's right. If it doesn't happen, then we know it's not a right triangle. So these two examples, I want you to work through them with your group and just determine if it's a right triangle or if it's not a right triangle. So go ahead and pause the video and do that now. Okay, and here are the answers to those two examples, so go ahead and pause the video again and check your work. Alright, moving on. We now have another way of classifying triangles. We're now going to be able to classify triangles acute, right, or obtuse by looking at the side lengths. And we're going to see that if certain things happen using kind of the Pythagorean theorem, then we can determine if it's acute, right, or obtuse. So starting on the left, if we see that a squared plus b squared is greater than c squared, then triangle ABC is acute. Now, when I say a squared plus b squared and c squared, this a, b, and c, what you're basically going to do is you're going to list them in order from smallest to largest. The smallest side will be your a, the middle length will be b, and then the biggest side will be c. So that's how you need to order these. The middle section says that if a squared plus b squared equals c squared, then triangle ABC is right. And this is just the converse of the Pythagorean theorem again. Our last inequality says that if a squared plus b squared is less than c squared, then triangle ABC is obtuse. So now let's apply these in a couple of examples. So all you're going to do is you're going to use these inequalities and see whether or not these triangles are acute, right, or obtuse. So I want you to go ahead and pause the video and work these out with your group. Okay, I'm going to start in the top left corner with the 3, 4, 5. So when we do this, we're just going to assume that it's equal to start off with and then see what happens at the end. So 3 squared is 9 plus 16 equals 25. Well, I know that 9 plus 16 is 25, so 25 equals 25. So this is right. We're going to go up to the top right. It's 5 squared plus 7 squared equals 11 squared. So that's 25 plus 49 equals 121. And 25 plus 49 is 74. And 74 is less than 121. So if a squared plus b squared is less than 121, then this is obtuse. The bottom left, 2 squared plus 3 squared equals 5 squared. 4 plus 9 equals 25. And it looks like 13 is also less than 25, so this is obtuse. Okay, the last one. It's 8 squared plus 10 squared equals 15 squared. So it's 64 plus 100 equals 225. 164 is less than 225, so this one's also obtuse. And I didn't give you an acute example here, but from working these, I'm sure you could figure it out.